السلام عليكم ورحمة الله تعالى وبركاته. الآن أعتقد أن الصوت واضح. أعتذر عن آه، المشكلة هذه الصغيرة. معكم عليان عبد النور، جي تي وزو الجزائر. اليوم بإذن الله سنتعرف على الكمبيوت انجين الأون بريميس وكثير من المفاهيم الجديدة. يعني ما هو الكلاود كومبيوتينج. الحصة ستكون بإذن الله بالإنجليزي، ستكون هناك حصص أخرى بالعربي أو بالفرنسي، وبإذن الله سنقوم مع بعض بالتعلم. سأكون معكم بإذن الله على الأقل مرة كل شهر. سأتناول مواضيع الكلاود كومبيوتينج، وبإذن الله في آخر العام سنكون كلنا قد تعلمنا، لأن التعليم لا يوجد أحد يعرف كل شيء. يعني سنتعلم الكل مع بعض، وهناك سيشنز عن اندرويد، عن كوتلين، عن ماشين ليرنينج، ويكون هناك بإذن الله عن كلاود كومبيوتينج. الآن طبعا إذا كانت لديكم أي أسئلة يمكنكم طرحها على الشات، وسنقوم بإذن الله بالرد عليها. سأبدأ بالتفاصيل الدقيقة. يعني حتى وإذا لم تكونوا من من عالم الكمبيوتر، سأحاول أن أبسط المفاهيم إلى الحد الأقصى. لكن إذا كانت لديكم أي أسئلة يمكنكم طرحها، لا مشكل. نحن هنا للتعلم، فلا تترددوا لطرح الأسئلة. Hello everybody, Azul Falon. I'm Aliane Abdenour from GDGTZUZU, Algeria, and together we are going to check and learn how about things about Google Compute Engine and on-premise and cloud computing, hypervisors, lot of stuff. We will be together in 1 hour, and I hope within this 1 hour we will get something together. If you have any questions, you can ask them. Ask them in Arabic, in French, in English, as you want. Okay, so we have the Google Compute Engine, but my objective, as this is the first session in a series of sessions, I will be with you at least once in a month in 1 year. I will try to go from the simplest concepts, from the basics, and then we will scale up again and again every session. So if you have any question, I'm here. Today we are going with the basics of the Google Compute Engine using the on-premise habits. First, what is the on-premise? And of course, there is attendance certificate. The on-premise, before we hear about those words, on-premise, cloud computing, let's check before this, when internet, in the beginning of internet. So this is it. We have just a small machine with an operating system. We have a keyboard, we have a mouse, we have a DVD player or a CD player, and we have a networking. This is the base of any cloud computing or a web server, or even what we are using right now. We are hosting some solutions on computers. So here is, for example, the first web server. And as you see, this is just a simple box, a simple machine. There is even a note here. This machine is a server. Don't power it down. So as you can see, the whole internet began with a simple machine with a CRT screen. So we have a server, and then we have a storage. And in the storage, when you host the solution, you have 3 types of storage. We have what we call a DAS, we have a NAS, and then we have a SAN. The DAS is what we use every day. If you have a USB disk, you are using a DAS. Why? Because you are using a direct attached storage. A hard disk or SATA disk is a DAS, but you have a problem. if this machine goes down, the storage goes down. This is not what we want. So what we did, we separated the logic, the business logic, which is the processor, for example, what I am doing with the mouse, the calculation, the if else, and so on, from the data access, from the disk. So the disk is what we call the data access. And the processor, the RAM, we call it the business logic. And we created what we call a NAS. A NAS is a network attached storage. What we do, we take our disks and we reserve a special server to those disks, and then we share those disks in a special protocol. For example, SMB for Samba. When you share a folder on Windows, this is called Samba. NFS for network file system, you share it on network. And the trend now is what we call iSCSI. We pronounce it iSCSI, which means Internet Small Computer System Interface. Don't worry, today it's about the basics, and then we will detail all of them. And then the NAS, you can install the free NAS. You can download the free NAS and make a NAS in your home or in your office. But professionals don't use NAS, they use SAN. SAN for Storage Area Network. This is really expensive. Why? Because we take a lot of NASs and then we make SAN, but the connectivity, it's not using regular connectivity. We are using the fiber optics, which are really, really fast. That's why it's expensive. So nowadays, you will always hear about SANs. So SAN is a bunch of NAS, and the NAS is a bunch of disks. That's it. That's easy. And then, because we are using a lot of disks, we need high availability. The high availability is assured using the RAID. You will always hear about RAID. RAID is for redundant array or of independent, or some people use the word inexpensive drives. What does this mean? We take drives and then we stack them in an array, and then instead of having one disk, we will have a lot of disks. And then the RAID, we have a lot of versions. We have the 0, 1, 5, 6, and 10. So there is the 2 and 3 and 7. They are not really used. So what we use in the industry is the 0, 1, 5, 6, and 10. Let me explain this using this tool. I introduce you this tool, which is called Jamboard. Jamboard is the new way that enterprises use to, for example, you have an idea and then you want to share it with your team. What you do, you take a tablet or your phone and then you draw something and other people will see the same thing. So let me put a full screen. Let me run the Jamboard on my phone. And then look that if I start drawing, let me make a smiley, you will see exactly what I am doing. And it's a collaborative tool and it's a free tool. You can use it, you can share it. That's exactly like what I am using right now with Google Slides and Google Docs. So let me free this and go back to what we were explaining. So here is a RAID. So if we have disks, let me draw 3. I'm sorry for my bad drawing. I'm a left-handy, so we have a disk 1, a disk 2, and disk 3. What means red is that if this crashes, our data is still there. Why? Because we still have this and this. So we have 2 disks that are still running. So why there are many versions of RAIDs? Just because this. So let me use the basic RAID. So let me, okay. let me clear all this. So we will draw the basic. So here is the first disk, and here is the second disk. So red 0 is that if we have A, B, C, and D. I hope everything is clear. What we will do with red 0 is that we will pick A and B, and then we will save them here. And then we will take C and D, and then we will save them here. So this is what we will see in other session about databases. That's called sharding. Sharding is fast. Why? Because if I wanted to reach the letter C, if I saved everything in the same disk, I have to go through A and then B to retrieve C. But because I sharded, I split the data, if I wanted to retrieve the C, it will directly go to C. So this is red 0. Now red 1 is, let me, okay, I hope the eraser works good. Red 1 is I take the same A, B, C, D like this, and then save it twice. I will send it first here, and then I will send it here. So that will give me redundancy. So in case of this one crashes, I will still have my data here. So this is red 1. And then we have red 10 to make it easy. Red 10 is the combination of redundancy and sharding. And then the other reds, 5 and 6, is that we save what we call the parity. The parity is, for example, if I send you data, the problem is that this data can change over network because it's electronics. There are really a lot of things that affect the data. So what we do, we save parity to retrieve the data as it was original. So what we do is to save the parity with the disks. So in case I crash, the disk crashes, I can go back and reconstruct the data. So those are the types of red, but this is not our subject. I just wanted you to understand what's going on in the server industry. But because we are in 2020, this is future. So you have to really take in account the SSD, because SSD, it's another technology. When they invented RAID, they invented it for the old technology disks, SATA, which is not like what we know with SSD. So if you want to check more, I advise you to check about ZFS. ZFS is a new way how server store data. ZFS, you it's a format, but at the same time it's a format like NTFS and FAT32 and EXT. But ZFS can also play the role of RAID. It's really good. Why? Because later we will see the concept of snapshots. Okay, here now we go to the networking. We explained simple server, and then we explained the data, and then we go to the network because we need three things. We need a server that makes a calculation and RAM, and then we need the disks to store the data, and then we need to connect those two machines, or the machine with the disk with the network. And then in the past, and even now, we use what we call the VLANs. VLANs, for people who did Cisco, it's easy. We have a switch. And then we try to split the data in a virtual way. I will explain you this. So let me go back to the dashboard. And as I told you, today is for beginners. I will try to give all the concepts, so next time I will not go back to them. Okay, here is a switch. And then we have the entries. So what happens is that, for example, you are in an enterprise, and then in the enterprise, you have this department, you have this department, and then you have this department. You have three departments. So you want to split the data for privacy. For example, you have the marketing data. They should not see what's going on in other departments. So what we do, we install three switch. We install three switch. This using hardware. So what we do, we bring the first switch here, another switch here, and another switch here. And then we connect all the switches to the original switch. But this solution costs money and more hardware and doesn't scale well. Why? Because if I add another department here, I need another switch, which is not good. So what we do, we take the three departments and then we isolate them using logic, not something physical, something logical. So we tell the switch, yes, of course, programmatively, that this department goes here, this department goes here, and that department goes here. And then we separate them logically in a way that one department cannot access to the other department. They are all isolated. So this is what we call a VLAN. A VLAN is a virtual LAN, LAN for local area network. WLAN is what you use at home because we call it wireless LAN, wireless local area network. So when you hear about VLAN, this is just this. This is how we are splitting our data. But the problem is that a VLAN works in a level 2, sorry, level 2 OSI. We need to go outside our LAN because when we are in an enterprise, we need to connect other enterprise to our network. And that's where we use NAT or a VPN. NAT is for network address translation. It translates our private address to a public address. We are using internet, which means that people know us with a public address. But when we are at home, we are using local address, what we call private address, or we use VPN. VPN is what I think a lot of people have already a VPN on their phone. For example, if you want to watch a movie which is not in your area, you use a VPN to make him think that you are in another area. Notice that there is a difference between a VPN and a proxy. A VPN is a layer, while a proxy is just another server who plays the role of you. Okay, so what is this L3, L2? Let's go back here. And then here is what we call OSI. OSC is a standard that represents layers about data, how data transits. So we have a lot of layers. We have 7 layers exactly. So what happens is that when you send data, you are transiting on layers. So every layer has only one job in a way that the superior layer can see what happens in the inferior layer, but the inferior layer cannot know what's going on with the superior layer. That's why when we use a VLAN, we are in a data link in layer 2. So every time you hear people from networking, they talk about OSI layer. So we are using internet, we are here. We are in application. Why? Because we are using a browser, so we need the whole stack to see the result. So this is what we call the OSC model. We will check about this in details in the network session. Okay, so now we saw how they were doing the networking, how they were doing the data. So now what is virtualization? Virtualization is just mimic what we already have physically. In the computer industry, you just add V. So you have a CPU. You want to something virtual, you will hear about vCPU. You have a disk. You will hear about ISO. ISO, where is it? And I think a lot of people already burned, for example, a game to a disk using the format ISO, ISO. Because in virtualization, everything can be virtualized, even the switches and the modems. But I'm talking about virtualization. Why I'm talking about hypervisor? The session about hypervisor, and then I am talking about virtualization and cloud, because the hypervisor is just a machine within a machine. That's the role of an hypervisor, is to emulate the machine on a physical machine. And we have two types. We have a type 1 and we have a type 2. But I need you to understand those two words, the host and the guest. The host is the machine where we are running our operating system. For example, right now, I'm using Windows 7, and this is what we call host. If you have a server, you are using, for example, Linux, you are using a machine that we will call a host. But when you virtualize the machine, those virtualized machines, we will call them guests. So we have a host, and then we have the guest. And we have two types, the type 1 and the type 2. The type 1 is a bare metal, and the type 2 is what we use on top of the operating system. But there is something I want you to explain, because we try to make things uh, in a deeper way. You need to know that even type 1 has its own operating system. So let me clear this. And I'm sorry. Okay, let me clear this. You need to understand that a machine is like this. As we saw earlier, this is like a OZ layers. So we have the hardware, which is here, and then we have the software, which is here. We are interacting in the upper layer, and the machine uses electricity in the bottom layer. And then here we have the operating system. And the operating system, why I put two parts? Because there is a part that we call the kernel. The kernel is here. And the kernel don't allow someone to go down. It's forbidden to go down. Why? Because imagine that you have a virus, and then this virus runs on Windows. The Windows, it will not allow the virus to go to the hardware, because there is that part that we call the kernel that doesn't allow him to go. And when you use the hypervisor, we need a small OS. This is not the operating system we know, like Ubuntu or like Windows, but he needs a small operating system to make those layers. So even in type 1, you need an operating system. And this is what I just draw right now is the difference about the resources. So when you have the type 1, that means that you are near the hardware, which means that you get everything. You get all the RAM, you get all the disk, you get all the CPU. But if you host another machine, that you will not get everything. You will get, like, let's say, half. And then if you host another host, that that will be even worse. Because in my demo, I will use this and then I will go compare it with Compute Engine. And of course, you will always hear about type 1 and type 2, but I prefer that you will hear those three types: the full virtualization, the para-virtualization, the hardware-assisted virtualization, and the hybrid virtualization. The full virtualization is that I take the machine and then I fully convert it. This is like emulation. So when you do the emulation, the problem is that you are using too much power. This is why full virtualization, you will find it a lot in 32 bits guess, which means if you want to use an hypervisor, for example, VirtualBox, and then you bring Ubuntu 32 bits and Ubuntu 64 bits, you will notice that 32 bits Ubuntu, it will be slower than 64, which doesn't make sense, right? Because 32 bits doesn't use a lot of RAM, but 64 bits, it uses the double of RAM because the bus, when you transfer data, you are using a double 64. But you will notice that 64 bits is faster than 32 bits. Why? Because you are using a full virtualization. But if you want to do a good virtualization where you will not notice some lags and then it will not be really heavy, then you will opt for para-virtualization and hardware-assisted virtualization. Para-virtualization, the best that we know is Xen server. What does Xen is that when you run Ubuntu, Xen will modify the kernel of Ubuntu. It will do some modification, so Ubuntu will know that it is being virtualized, which is not the case here. For example, if I virtualize Ubuntu in 32 bits, he doesn't care. He thinks that he is running on a real machine. But in para-virtualization, he will really know that he is being virtualized. Why? Because they will play together, and we will see that just in a few seconds. Don't worry about this. And the hardware virtualization is a new technology, not really new. This is when you have, for example, a laptop like E3, E5, E7, or Ryzen 3, Ryzen 5. So those technologies, they have a CPU. You need to find those two words. If you have E3, E5, E7, you need to find that word, Intel VTX. But if you have an AMD Ryzen, you need to find VTD. So what happens is that when they invented the x86, which is the commodity server, what we use every day, those laptops, their architecture, it's called x86. When they invented it, they didn't projected in the future that it will be used for virtualization. So now that everyone is using virtualization, we need a new architecture. So what they did, Intel and AMD in 2005 and 2006, they created a new registers for people who using the register is, I give you an example. You hear Windows on phone and Windows on mobile. It is the same Windows, but you cannot run a software on phone and the same on your laptop. Why? Because the architecture. The architecture the architecture of the for example of the mobile is what we call, for example, ARM, but your laptop is using another architecture, which means that you cannot do that. You need to emulate. That's why when you install Android, you need an emulator. For example, HAXM. This is for Windows, but on Linux we will see that in a few seconds. So to enable this, just a command for people who using VirtualBox, we see all that later. And then we have the hybrid virtualization, they use the both. So to wrap it up, the para-virtualization, you modify the kernel, and then the kernel of the host, of the guest, it will know that it's being virtualized. And the hardware assisted that you need a special architecture. And you need to enable that from your BIOS, because by default, I saw a lot of machines that are disabled. And the hybrid, they use the best of those technologies to deliver what is fast. So, because our objective is to teach everyone, it's not enough. Let's draw what I just said. So let's go back here. Okay, here is what we call the architecture of x86. So this architecture, okay. So the ring 0, I will use this one, okay? And this is the ring 0. The ring 0 is where the kernel happens. And then we are using, for example, Google Chrome, we are here. Google Chrome is running on ring 3. Ring 3 is what we call user space. Ring 0 is what we called the kernel space. So what happens when we do, for example, a para-virtualization is that, for example, Xen server, it creates a clone of ring 0 that we will call DOM 0. Let me write this, DOM 0. DOM 0, it will mimic the work of the ring 0, and everything else, we will call it DOM, we will call it DOM U. So DOM U for user space, and the DOM 0, the DOM is not for people web, the DOM, it's for a domain. So the DOM 0 is the kernel, and the DOM U is the user space. That's why when you try to share, for example, your screen or your camera on Google Chrome, it will ask you for permission, because the camera is in ring 0, it's here. You need the driver, because he needs to confirm that this is not a virus who tries to do something wrong. Okay, I know those concepts are weird, but trying to do my best to explain you those ones. So sometimes you will find some hypervisors that are already present in your machine, which is the case virtual PC. It's disabled. You can enable it on Windows XP. Hyper-V, for people coming from Microsoft, they have already on Windows Set Pro. Notice that on Home Premium, it doesn't exist. And then if you have Windows Server, of course, you have this. Behave on FreeBSD. There is a fork for people from Mac. And then what's important here is KVM. KVM for Linux kernel module. And this is what Google uses in Compute Engine, but they don't use QEMU. QEMU for quick emulation, some people thinks that it's the same, which is not the case. So you use QuickEmu, which is an hypervisor type 2, like VirtualBox that we will use in a few minutes, but so quick emulation, we need it if we want to emulate, for example, Android, and we need to emulate Windows XP or Windows 98. But when you use something on the cloud, generally you don't need those kind of OS. You need, for example, Windows Server, you need Ubuntu, you need Debian or CentOS or Red Hat. Those operating systems are professionals, and because it's limited, Google decided to not use QEMU, because if in QEMU you complicate your system, which means that you will have problems in security. In the slide later, you will go to this link, and then you will have a lot of information. This is the difference between QEMU and KVM. Here is the hardware, and then here is the KVM. The KVM works with QEMU using libvirt. And this is why people think that QEMU is the same with KVM, because they are used together. And we need to virtualize disks too, because here we virtualized CPU, and then here we need to virtualize the disk image. The disk image, there are many formats depending on which hypervisor you are using. So if you use KVM or Xen, you have this format. If you have KVM for people coming from Windows with Hyper-V, they have this for VMware, for VirtualBox. But the best that you can see is RAW, because this one is standard. It will work on of this and even on Google Compute Engine. If you want to convert, there are many tools and they are free. For example, you have VMware, and then you are in an hypervisor that doesn't have VMware, you can convert it to RAW to make it happen. And there are two types of disk, because we are everything is virtual, which means that it's just a program. So this, we have the thin provisioning, and then we have a thick provisioning. Thin provisioning is that I reserve 1 tera, but it will not use 1 tera in my disk. It will use as I use it. For example, I reserve 1 tera, and then I installed something that have 20 giga, it will only use 20 giga. But thick provisioning is that if I reserve 1 tera, it will reserve 1 tera even if it's empty. And then don't mix those format with the virtualization, the virtual appliance. Sorry, virtual appliance is if we want to export our machine as it is with the disk, with the configuration and all, and we want to put it on Google App Engine, for example, then we need to use one of those two formats, which are OVA and OVF. OVA for Open Virtualization Appliance, and OVA for Open Virtualization Format, which is the same. And then if we want to virtualize our VLAN at a large scale, then we will use the VPC. VPC is for Virtual Private Cloud, and this is the base of GCP. And then some people want to script those. For example, if you have your machine goes down, we need a script that makes it up without repeating the same procedures, and then we use what we call infrastructure as a code. We have Vagrant and Terraform. Vagrant, for example, for VirtualBox, Terraform and Ansible and Chef and Puppet for the hybrid cloud. And sometimes our machine goes down. That's why we need to place it somewhere else, and that's we call live migration. Live migration, they have many names. For example, vMotion for VMware, Hyper-V, we call it live migration, and VirtualBox teleportation. But there is a problem. There is always a problem. How this works, and I will explain you this. So let's go back here, and let's free this dashboard. And okay, let's clear this. Okay, we have, let me draw two clusters. This is our cluster, and this is our cluster. Cluster is just a network. And then in the first cluster, we will place our machines, our hypervisors. In the second cluster, we will place our NAS or SAN for our disks. Logically, our disk is here, which means that our virtual machine saves the data here. So in case this machine crashes, because the hardware, it's not perfect, it will crash. What we do, we take the image here, and then we bring it back to another machine. And that's why earlier I told you that we need to separate the logic from the data. And that happens a lot in GCP. Sometimes they tell you in GCP, what do you want in case of maintenance? Because the engineer at Google, they need to do maintenance for the hardware. So what happens if you choose the live migration? You will not reboot your machine, or you will have another choice that you will tell them, okay, you can reboot it. So the live migration, this will happen in a few seconds. I saw an article, this is less than 3 seconds. So you will not notice this. Your machine will be slow, but it will not go down. And this is the live migration. Okay, and what I just explained to you, VMware and VirtualBox, this is not enough. You need the whole a whole solution, and this is what we call an orchestrator. So for the orchestrator, if we talk about VMware, we don't talk about VMware player or VMware server. We talk about vCenter, because the vCenter is the one that manages everything, the network, the disk, and so on. You will find the Cloud Stack, the OpenStack, Proxmox, OpenNebula, and Apache Overt. Those are open sources. Here is an example. I have our Cloud Stack, and I try to manage a lot of hypervisors, and then at the end, people will only see an e-commerce platform. But there is something important. I explained to you how things work in on-premise, but don't rely on an on-premise. Why? Because you need to know the difference between something free and something that you pay. So people now always talk about open source, but you need to know that open source doesn't mean the right solution for you. Why? Because you need the knowledge. So, for example, you install Ubuntu, it's free, but what happens if that goes down? What you are going to do? You need someone, you need an engineer, you need the knowledge, you need to pay them, because time is money. This is why there is the solution that we call the turnkey. So even if you find a solution that it's open source, for example, OpenStack or Cloud Stack, there is always another solution that you have to pay, because you will pay the knowledge. You don't pay the tool itself. Now, here is Google Compute Engine. This is the AIS for Infrastructure as a Service. Why you need Google Compute Engine? To not break your head about all what I explained to you. So instead of understanding what is the what is the RED, what is the KVM, and so on, you just host your solution on Google Compute Engine, and then there are engineers that do their job. And you have to know one thing: when you have an on-premise, you need to know that if you have your disk goes down, you need to go and buy another disk. But when you have an infrastructure as a service, you don't buy the disk. The people where you host your solution, this is who will buy the disk for you. So you keep in mind this, because that doesn't mean that it's free, that's the good solution for you. You need to look in the future how much money you are going to invest. And Google Compute Engine, their network is on a new technology. It's called Andromeda, which is a software solution. They made an amazing solution that it's like as fast as optic fiber. So you need to check about this. And then in Google, you have the concept of the zones and the regions. So you have a region contains zones. And if we don't talk about regions or zone, just look at this as data servers. So when you, for example, I'm here in Algeria, the best that I can do is to host my solution in Madrid. Because you need to know that in Google, this is not regional, this is global. Your resources are global, but you need to host your solution in a region, and then it will see all the network as global. So the first time I tell him, okay, I'm in Algeria, that's fine. I will host in Madrid, and it will be in future, but soon. If you are here in Middle East, you have Doha. So they try to put a lot of data centers everywhere in the world. And I know I was a little bit slow on explanation because my objective is that you understand what's going on. So let's see some demo, because this is where we are here. We are here for a demo. So let's see a small demo. Here is my VirtualBox, and then I need you to enable the Quick Love free month and come to the creating a virtual machine. But before this, let me show you how VirtualBox works. This is a type 2 hypervisor. Why? Because I'm using it on top of Windows 7. It is treated exactly like Google Chrome. I'm in a user space. I'm not in a kernel space. So what happens? I created a lot of machines, and then if I do new, what you need to do is just choose what you want. For example, my Ubuntu, and then the type. Oops, sorry. The type of your machine, Linux, and then you have 32 and 64 bits. I explained to you that better to choose 64 to have a real emulation and not a full virtualization, which is really slow. And then we give him the RAM. Look that I am limited because I'm in type 2, which means that I cannot tell him I will use 8 giga because my machine have already 8 giga. So I need to stop just here. You see, I have lost 3 giga. So if I want to use the whole 8 giga, I need a type 1. So I will tell him, okay, let me use 3 gigabyte of, and then I will create a disk. Just do okay. This is the VDE. This is for box. You can choose other format, but let's make it by default. And then next, and then the dynamically allocated. This is for thin provisioning and thick provisioning. So let's do it thin provisioning because I don't need to. If you check, I don't have 2 terabytes on my laptop, but it will allow me to do this. Why? Because I'm using thin provisioning, which means that fill it until the end. And then when I do start, it will ask me for a DVD because this machine doesn't have anything. So I need to go here and then place my disk and then start the installation of Ubuntu. I have already a machine that is already installed. So let's check with this. Let me go here, power off. I still have 10 minutes. Okay. Let me power on. So if I have enough RAM, you need to know that I can run all those machines in the same laptop, but I need a lot of RAM. So let's wait. Okay. And then I will show you an on-premise solution. And then this is Ubuntu. Notice that right now I'm using KVM. Why I'm using KVM? Because let me zoom here. So if I zoom here, you will see that the para-virtualization interface is KVM. Why I'm using KVM? Because this is Linux. And because I'm trying to virtualize Linux, I can modify the kernel. If I virtualize it Windows Server, they will use the Hyper-V. So if I come here, just an example for so you can understand, and I come to System and Processor, you need to see this one. This is not para-virtualization. This is a hardware-assisted virtualization. But if I come to acceleration, I will find Hyper-V and KVM minimal for people who comes for on Mac OS, and then none. There will be no virtualization. There will be like a fully emulation. And then here is for example, and some catalog tools. Cloud Stack is what you use in this is password. So I will try to. What is the I think admin and password. Perfect. They allowed me to add 10 other minutes, so we are in time. So, okay, let me, since I have enough time, this is, I will try to SSH to my machine. SSH, because you need to know that if I come here and then I will do servers and then I go to Google Image, you need to understand that the servers don't have a screen. They don't have screens, which means that when you download an operating system, don't download an operating system with an interface, with a graphical interface, because you will bring other problems with you. You bring other viruses because you need to handle everything. So what we do, we access to them using SSH for secure shell, so we can interact with the machine. So imagine this is a machine, but I cannot zoom on the letters. That's why I'm going to use this tool. You can use PuTTY, for example, or you can use Commander on Windows. So let me SSH on this machine. Oops, this is not my IP address. So 56, and then I will type my password, and then I'm in. So if I do the enter the IP address, this is a private address, and I'm not going through the switch because this is 56. If I go through the switch, I will have 1, and this is what we have in the networking here. You can choose to have a NAT, which means that you can access to your machine, virtual machine, but your guest, but the guest cannot access to the host. But if you use host only, you will create a private network, and you can use the bridge. And in the bridge, I will go until I will have an address to be visible outside the machine. But right now, I use it the host only, which means I cannot access from my phone, for example. Those kind of networking, we will see them in future. So let me go back to Cloud Stack. So Cloud Stack default, sorry, default password, and then default is admin and password. And that's what I did. Admin and password. Why it's not going? Number to region. Okay, no problem. Let's not use this. I will shut it down and then directly create. So here is how we use QuickLab. QuickLab, it's not a free solution. You need to understand this. People pay for QuickLab, but I think they have already shared with you the token. You will have a free month that you will access to Google Cloud Platform for free, 1 month. But you need to understand one thing: don't use it outside the lab, because you will have a quota, and then they can control you. You have what we call the APIs. They have only some API enabled for your lab. So if you try to go beyond what is reserved for you, the quota, they will block you because you are using it for education. You are not going to use it for something else. And then I will use subscription. I will open a new console, and then to make things to not have problems with your login, better to open an incognito tab, and then you copy this link. You copy this link, and then you paste it here, and then you copy this one. This is not arrobas at Gmail. This is at, if I come here, this is at quicklab.net, but this is the same. You are on GCP. So I will paste it here. Even if it's asking your Gmail, don't put your Gmail, put the at quicklab. And then I will pass the password here. I still have 15 minutes. Okay. And then I will create, confirm. This is like a standard way. It doesn't need to explain like in a complicated way. This is just something like next, 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 I accept. Okay, now I'm in GCP, Google Cloud Platform. I'm sorry for this bad connection because I opted for some weird connection where I have the upload is better than the download. So because I'm sharing my screen, I need upload data, not download data. I didn't thought that it will be really slow like this. This is my connection, don't worry. Sorry for this. So waiting for this to open, let me check if you have questions. Let me take the phone and check if you have questions. Still have 10 minutes. Okay, go to YouTube and so if you have any questions. Okay, finally it loaded. Here is the platform GCP, Google Cloud Platform. And then you have all this data. Don't worry about this information. We will go through them because we have 1 year with you. Because the next session, I will not talk about generalities. I will directly go to what's about Google. So I will do, I agree. I don't need to receive an email because this is a temporary account. And then I go here. As you can see, it's separated. Let me zoom like that so everyone can see. So as you can see, they are separated. You have compute, you have storage, and you don't need to understand all the concepts I told you about them. So let me come to Compute Engine, and then I will pin it here. So even if I go down, it will be still here. This is just an interface. And then let me go to Network, VPC Network, and then let me pin this. So if I come to VPC Networks, this is virtual private network. As you can see, you already have one VPC that is configured for you by default. Why? Because if you don't have a VPC, you cannot run a virtual machine on GCP. So the base is this. And then it comes the machine. But before we talk about the machine, you need to understand those addresses. So, oops, right. Those are private addresses, which means that every region has its own network. So if I come here, let me unzoom. So if I come to US Central, they have their network. Europe, they have their network. US West, they have their network. But because they are private network, but they can't talk to each other. And this is the same in VirtualBox. If I come here and come to network, and this is the host only adapter. What does this mean is that my machine is Google infrastructure, and all those machines, they can communicate with each other, but they are not visible outside. So by default, I can opt to not be visible outside. I will just let them talk to each other in a private network, because those addresses that are like this 10 something 00, they are private address. And then if I go back here and then go to Compute Engine, I will create a machine in a fast way. Okay, so you just do create, you don't need anything, but there is something that I need you to understand. When I create a machine, when I'm home, it will ask me to install from an ISO. I will download Ubuntu and then install it by myself. But when you are in an IaaS, in an infrastructure as a service, you will find a pre-built, pre-installed machines, because you don't have time to waste, because the time that you are using it, you are paying for it. So I will name it hello. But there is one thing in QuickLab, you need to respect exactly what they say. If they say name it hello, you name it hello. So because I'm not going to go until the end, I will just say hello. And then the labels, you need the labels because, let me zoom again, because when you have a lot of machines, you need to search, for example, let me call this web server. So server, and then I call it web. So next time I can search on web, because I will have other database. And then the region, you choose the one which is near to you, because you have the network you need, because going to USA, it will take more time than going, for example, to Italy. In my case, I'm in Algeria. So you need to choose the region that is near to you. Once you use the region, you use the zone. And then you have the kind of machines. You have E2, N2, and those ones are the old machines. So if I come back to the slides, you need to see that if I zoom here, the N1, they had only 6 gigabytes by vCPU, but the second generation, they have 8 gigabytes. So you better go to to the new generation, because you will have more RAMs by vCPU, virtual CPU. So I will choose E2, and then you choose the RAM. The more RAM, look here, that costs $24. But if I take more RAM of the interface, let me unzoom. Okay, that's better. So if I take another machine that have much more RAM, for example, 128, look that I will pay more. So it will calculate how much it costs. But remember, some people will say, hey, it's expensive. But you need to know one thing. When you host something in your own, if it goes down, you will pay for those things that are broken. But when you host something at someone else, even if it's broken, it's at the it's where you host that you don't care about paying the charge, because you pay once and then you don't care anymore. But when you host it in your own, you need to take care about everything. And then if I come to the disk, I created how much RAM, how much CPUs. If I do change, you need to understand that what I said earlier is that Google don't use quick emulation. Why? Because they don't need something like Android on the cloud. You just emulate it by your own. So they use KVM to make to emulate professional servers. And Windows Server, they will use the Hyper-V. And if you are not satisfied about this, you can say, okay, I want a custom image for another machine that we will do in next lab, where you can stop a machine but still keep the image, or you can upload your own machine. And the snapshot, what is a snapshot? A snapshot is that if you have running machine, for example here, let me run the XCP NG, This one, I'm pretty sure that it will work. I still have like 4 minutes. I hope it will. I will show you how Xen works. And I will run it. It will take time to construct the DOM0 because we said that that Xen makes the DOM0. You need to make the DOM0 which is bigger. Here is the GCP engine, because this is the DOM0 that allows more RAM for other machines. By the way, GCP Engine is the open source of Xen. Xen was bought by Citrix. Citrix made it not open source. People got mad. So what they did, there is an enterprise who made an interface which is called Orchestra. They took the source of Xen and then they made it open. So if you want to use something like Xen, but for free, you download GCP. But GCP, they have another solution, which we said about the turnkey, that there is a premium service that they will help you in case you have problem. So I'm waiting. Sorry. So the snapshot is just something that if I run my machine and then I do a snapshot, it will take like what is my disk at that time. So in case my disk crash, I can go back and get back what I was using. I'm really sorry because I don't know why it didn't go. I hope you understood with at least with VirtualBox. And then if I come back here, I will use a public image, Debian. So let me use Ubuntu, for example, fast Ubuntu. Then I will use the latest LTS, and the disk I will reserve, for example, 50 gigabyte, and I will just use create, and it will create a machine. But if you want something advanced about networking, you come to networking. That's what we will do in next session. If you want to crypt your disk, you can use Google Managed Key, or you give them your own key, but if there is a problem, Google cannot make it back. And you have the secure boot. If you have a Windows, you can turn it on and you just do create. It will create a machine and then access to it using SSH. This session was a lot about generalities. So I hope you understood what is an on-premise and what is virtualization. There will be other session where I will details only Google Cloud tools, of course, with examples. If you have any questions. Finally, here is Xen or XCP-ng. And as you can see, there is no interface about Xen. So what you need to access to this IP address. So let me access rapidly. And then you will have this interface. This interface will send you to download or Xen Orchestra. But I have Xen Orchestra here. Just give me 5 minutes and then I will finish. I just want to show you how an type 1 works. So if I come here, load, 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 load. If you see the RAM, my machine is suffering, but that's fine. I just want you to understand a lot of stuff. Okay. Okay, just load, just load. We are in hurry. There is a joke that says that a computer, you should not be stressed near the computer because it's like a printer. The more you are hurry, the slower it gets because he feels your stress. Okay, I finally accessed it. So let me go here, SSH, and Okay. Just give me the access. I need to show them something. Okay, finally. And because I downloaded Xen Orchestra here, so that's just an interface. It's a Node.js application. So I just ran the node and I compiled it by myself instead of downloading the whole image, because what gives you, it gives you an image where you need to download a Debian image. So what I did, I installed everything on Ubuntu, and then finally I come here and then change this to 85 because I need to access the machine, this machine. Okay, just give us what we need. Next time I will bring another box with 32 gigabyte because I was going to do this in this session. Sadly, there were some stuff and we could not do that. So next time I will be ready, I promise. Okay, just it seems that I went out of RAM, I'm sure. Okay, I will check about question. If there is question, I prefer to let this. Is there a price plan up to use? Which price? Which platform? GCP, Xen. Uh, yeah, by the way, the presentation is free, so please share it here so they can check. Okay. Back. Okay, I ran out of RAM. That's why it didn't work. So as you can see, maybe that's a good thing, because this is what happens when you host something by your own. You need a lot of RAM. But when you host something on GCP, things don't work on your laptop. The stuff works at Google, which means that even with a Chromebook, even with the phone, you will be able to run machines because you will only need to run the browser, nothing else. But if you have your on-premise solution, then you need a strong machine. Okay, I will just the last time and then I will end. If it doesn't work, I'm sorry. Okay, so sudo fw disable. Let me disable this, and then rerun Xen because I'm using a bridged interface. That's why it do this. Okay, finally it worked. So here is what you will do. Will have on your on-premise. So if I come to the dashboard, and then I will create a new machine. So if I come to, you see that there are some services that they are premium. That's what I told you. When you have something free, this is not always free. And then you will do a new virtual machine, the server to Xen server, and you have the same thing. As we saw earlier, for example, I will choose Ubuntu, and then I need an image from an NAS or a SAN, and then I will run it. That's the same thing that happens with Google Compute Engine. That's it. I'm sorry things didn't work as expected. This is the direct. So for Compute Engine, sorry, this is the question. You have a lot of plan. So depending about what you need. And you need to understand that there is a special plan that it's called a pre-implementable machine, which means that it costs less and it will run for 24 hours. So if you need something cheap, you just go with those ones. Or, for example, you can choose here a shared machine. So let me go back here, and there are N2, and if I go here, I'm sorry, with this interface, it doesn't work, it doesn't help at all. So you can run with this. For example, look at this micro, this is the free plan. You see? You can even have the free plan. So if I come here, you just go to GCP free plan, and then it will give you some offers. You already have $300 for free, and then you have the free tier. This means that you already have 300 and plus all this. So if I come to Cloud Engine, Compute Engine, sorry, then here is what you get for free. This machine is free. You just need to put your credentials, and then you start a new machine. Thank you very much. I'm sorry it didn't work like expected. See you next time. Thank you.